Maths is awesome, maths is fun, maths is there for everyone.
Welcome back, Year 8. Now we're going to be looking at more volume questions, and we're going to be dealing with the volume of prisms and cylinders. So let's have a look at this. What I want you to imagine is that you've seen a tissue box before, so there's a tissue box. If you pick up a tissue box, what's the actual name of the shape? Well, it's not a square, it's not a rectangle, because it's three-dimensional. It's actually called a rectangular prism. Now we've talked about prisms when we dealt with surface area, but let's actually now get into what makes a prism. Well, a prism has to have identical ends and flat sides. Now the ends can be anywhere, like it could have this left and right end, they're identical, and all the sides are flat. Or it could be the top and the bottom, they're identical, and the sides are flat. When you talk about ends, it's one end to another end. So you've also got the front and the back. There's three different ways a rectangular prism is a prism. A cylinder is not a prism. If I actually think of a cylinder, well, if I actually have a look at it, it's got identical ends because that end is a circle and that end is a circle. So it does have identical ends, but the sides between them, well, it's actually rounded. They've got to be flat sides in order to be, or flat sides in order to be a prism. Even though a cylinder works using a prism formula, it's not a prism. So what we're doing is we're going to call the cross-section constant. Now what a cross-section is, if I have a look at, imagine, well actually let's make this a bit different. Imagine my picture now looks something like this. There's my tissue box type shape. And imagine that wasn't a tissue box, it was a rectangular loaf of bread. When I actually cut slices, and remember, if I was to take the left hand and the right hand edge, or left and right hand faces as my identical ends, then what I can do is I can get a knife and I can start to cut, and if I cut, I would cut a slice of bread. When I cut the next piece, it's another slice of bread, and the next one, another slice of bread, and the next one, another slice of bread, and every slice that I cut would have the exact same shape, and the shape would be the shape of the end pieces. Now how thick it is depends on how thick you make the slice, but every slice would have the same shape as the end piece. And then we determine the thicknesses, and we deal with that when it gets a bit more complicated later on. So that's what a prism is. A prism is something where you have two end pieces that are exactly the same, and you can take slices, and the slices are called cross sections. Now, when we deal with our formula for a prism, we have a prism. The volume is the area of one of the end pieces. It's like the shape of the slice, if you like, times by the height, and the height is the distance between the front and the end slice. So if I look at this diagram here, I can see I've got a shaded triangle on the bottom. I also could shade that triangle on the top, which means I now have a top and a bottom that are the same shape as each other. All of the sides that join those two shapes are straight, that's now a prism. So if I take the area of that shaded blue bit, doesn't matter if I look at the top one or the bottom one, and times it by the height, which is the distance between those two blue bits, then that will give me the volume. The same thing applies for the cylinder. I can have the circle on the top and the circle on the bottom. I find the area of a circle is pi r squared, and h is the distance between those two circles. So there's my formula for the area of a volume of a cylinder. So let's look at our first example. It's just 4 different shapes, and the question basically says, Tell me whether or not the following are prisms. Well, if I look at the first shape, there's different ways I could do it. I could take that end piece there and that end piece there. Are they the same size as each other? Yes, they are. And the sides joining those two end pieces are all straight sides, so yes, it is a prism. When I look at part B, I can say, oh, I've got a triangle at the front and a triangle at the back. Are they the same shape as each other? Yes, they are. Are they joined by flat sides? Yes. So, yes, it's a prism. When I look at part C, it doesn't matter which sides I could look at one, I could say, oh, there's a triangle, but they're not joined by flat sides because this triangle is actually touching this triangle and they can't do that. So no, that's actually not a prism. I can't take slices where each slice is the same size as the previous slice. And the same for part D. I've got a circle on the top. I can't take slices all the way through and all the circles are the same size. So that's not a prism either. So we won't be worrying too much about questions like C and D. We'll deal with those in years 9 and 10. So let's find the volume of some shapes now, and then we've got to have to convert the answers back into litres. So this is a cylinder. We've got a formula for the volume of a cylinder. It was on the sheet, and there's our formula. Volume equals pi r squared h. We just need to memorize that formula if we want to do these questions quickly. The radius is 2 centimeters. The height is 4 centimeters. Be careful, if I had the diameter, I would have had to have halved it to get the radius. So it's pi times 2 squared times 4. Put that into the calculator, and it's 50.265 cubic centimeters. But it wants the answer in litres. Well, I know that 1 cubic centimetre is equal to 1 millilitre. So 50.265 cubic centimetres is 50.265 millilitres. And a millilitre is 1,000th of a litre. So I'm going to divide it by 1,000, and there is my answer, 0.050265 litres. Very small indeed. Part B, there's my shape. Now, for this question, it's a bit more challenging. What I need to do is recognise that I've got a triangle at the front. I also have a triangle at the back, but I'm not really worried about the back triangle. I'm just going to focus on the front triangle. So the volume is equal to the area of the front triangle or the back triangle, doesn't matter, times h. Now normally we use a little h here. You'll see why I've put a capital H there in a moment. What's the formula for the area of this triangle? Well, it's a half base times height. Hey, that's got a little h in it. Well, that's why I've used a capital H here, because this h means the height, which is the distance from my front triangle to my back triangle. So in this case, it'll be 8 centimetres. This little h is the height of my triangle, which is 5 centimetres. So for my triangle, the base is 4.5, the height is 5, and capital H is the distance from the front to the back of my shape, which is 8 centimetres. Put that into my calculator, and I get 90 centimetres cubed. Now I know 1 centimetre cubed is a millilitre, and a millilitre is 1,000th of a litre, so it's 90 divided by 1,000, which is 0.09 litres. Now looking at part C. With this question, it actually looks harder than what it is. You can see we've got an area down the bottom. That's the same as this shaded area up the top. So I need to find that shaded area and then times it by 8 to get the volume. Now, how do I find that shaded area? Well, I don't have to. I'm told what it is. The shaded area is 15 centimetres squared. So where I see shaded area here, I can just put 15. Where I see H, it's 8 because there's 8 centimetres from the bottom to the top. So 15 times 8 is 120. How do I convert that to litres? Well, 120 cubic centimetres is 120 millilitres. A milliliter is 1,000th of a litre. So I'm going to do 120 divided by 1,000, which is 0.12 litres. Part D. This is a weird looking shape. Is it a prism? Well, yes it is, because I've got this shaded area at the front and the shaded area at the back that are the same as each other. So what is the shaded area at the front? It's called a trapezium. And there's the formula for the area of a trapezium. I put square brackets here because I had a rounded bracket already in the trapezium. You don't really need those brackets at all. So I also put a capital H on the end because I didn't want to get it mixed up with the little h that's in the trapezium area formula. The little h for the trapezium is, let me just undo that, the little h for the trapezium is the height between the two parallel sides, so it's going to be 0.6 because there's my parallel sides. The capital H is going to be the distance from the front all the way to the back. So the little h is 0.6, A and B are my parallel sides, 1.5 and 0.8, or you could have 0.8 and 1.5, the order doesn't matter. And capital H is a distance from the front to the back, which is 3. I put that into my calculator, and I don't need the square bracket, so that's okay, but I do need the brackets here. And I get an answer of 2.07 cubic meters. Now, a cubic meter is 1,000 litres. So if I want to convert that to litres, 1 cubic metre, I have to have 1,000 litres. So I times this number by 1,000, and I get 2,070 litres. Because remember, for 1 cubic metre, that holds 1,000 litres. So I've got a bit over 2 cubic metres, so it holds a bit over 2,000 litres. This shape's a composite shape. It's a bit trickier. When I look at this, if I look at that left-hand edge, it would be the same as the area of the right-hand edge. So what I'm going to do is I'm going to find that area there and times it by 50 because there's a 50 metre gap between the left and the right-hand shapes. So my formula is the volume is the area of my end piece times by h, which will be 50. Well, the area of my end piece is the area of this rectangle and the area of this semicircle. If I have the area of a rectangle and the area of a semicircle and I plus them together, I get my composite shape. So, what's the formula for the area of a rectangle? That's length times width. What's the formula for the area of a semicircle? Well, that's, I should write the formulas here. The area of the rectangle is length times width. The area of the semicircle is 1/2 pi r squared times h. Now, when I look at this, because I've got an r, I need to look at this and go, I don't know the radius of my semicircle. I know the diameter is 20. Half of 20 is 10. So I now know that that's 10. So looking at this, lengthen the width of my yellow rectangle on the end. The length is 20 and the width is 15 because it's 15 metres high. 20 by 15. Plus 1/2 times pi times, what's my radius? My radius is 10. 10 squared. And then I times it by 50 because that's my height from the left edge all the way through to the right edge. Put that into the calculator. Now, with this calculator question, this is actually really important that you actually do need the square brackets and you don't have square brackets on your calculator. So what you're going to do is use a rounded bracket. And you're going to go left bracket, 20 times 15, right bracket, plus left bracket, 1/2 times pi times 10 squared, right bracket, times 50. If you do that, you'll get your answer of 22,853.98 metres cubed. Now, part B, same deal, composite shape. If I look at the end pieces, I've got two rectangles. I know this height here is 10, that's 8. The full height's 18, so 8 and 10 make 18. Looking at this distance here, I know that this is 16 How do I know that's 16? Because that's 7, and that distance there is the same as that distance there, which is the same as that distance there, which is 9. 7 plus 9 is 16. So I've just figured those out and written them on the diagram. Now the formula for this shape to find its volume is the volume of this cross section, and remember at the back it would be the same, times by the height, which is 42 centimeters. That's height. The height is the distance from the front to the back. So it's the area of the blue rectangle plus the area of the green rectangle multiplied by 42. Well, the blue rectangle is 8 times 16, length times width. The green rectangle is 10 times that distance there, which is 9. And I'm going to times it by 42 because 42 centimeters from front to back. Again, you don't have a square bracket button on your calculator, so you use a rounded bracket. So you're going to go left bracket, 2 brackets in a row. 8 times 16, right bracket, plus left bracket, 10 times 9, right bracket, times 42, and that'll give you your answer of 9,156 cubic centimeters. Time for you to try some questions. Enjoy. Bye for now.